Hi everybody, this is week 1 and this is our first example. This is problem 112. We're looking at this differential equation and the question is what were the dependent and independent variables and what were the parameters. So here the dependent variable is p. Because that is the variable being differentiated. The independent variable is t. And you can tell that this is a first order equation. Because there's only one derivative that shows up here. And that answers the question. I wanted to discuss this further because it's an example that we're going to see later on. In this case, t we think of as time, and p we think of as the population size. And in this case, r and k are the parameters. The parameter r is typically thought of as the growth rate for the population, because if you ignore this, the growth rate of the population is typically proportional to the population. So if the growth rate is 2%, then r would be 0.02. Meaning at every time period, the change in p over that time period is 0.02 times the population that was there in the first place. So we typically think of r as being positive. And k is a little harder to understand. We think of that as the carrying capacity. So the population, if r and p are positive, the population is growing until this second portion turns to 0. Which cuts off growth. That happens when p is equal to k. And so then we have 1 minus 1, which is of course 0. And so at that point, growth is cut off. And if p is larger than k, then of course there's a decrease in the size of the population over time. And so that means that the carrying capacity has been exceeded. So that's why this is thought of as the carrying capacity. So r and k are the parameters. We'll see this equation again. It's called the logistic equation. And it's one of the examples that we will analyze in a number of different ways. And it's a standard example of a differential equations model for a biological situation.